Welcome to Mastering Solutions. This is a pretty fun vector problem where they tell us that Josh is climbing up a steep 34-degree slope. So let's draw that. So here's his 34-degree slope right here. He's moving at a steady speed of 0.75 meters per second along the ground. So when it says he's moving along the ground, that means along the ground relative to him. So it will be this portion right here. How many meters of elevation does he gain in 1 minute of this climb? So we need to find the y component of his velocity right here, and then we'll convert that into, from meters per second, we'll convert that into a distance. And then we'll take that speed because we just want the vertical component of it because we're looking for elevation. So once we have his vertical speed, then we'll take that and use kinematics to find how far that is in 1 minute. We have a right triangle here, obviously, so we can use trigonometry functions. We have the opposite of the angle, which is what we're looking for, the y component. So we'll use sine, obviously, which is sine of the angle is equal to opposite over hypotenuse. That comes from SOHCAHTOA. Obviously, we've talked about it in a lot of other problems. And we want to isolate the opposite. So let's multiply both sides of the equation by h. So now opposite is equal to h times the sine of theta. 0.75 meters per second is our opposite times the sine of theta is 34 degrees. So 0.75 times the sine of 34 gives us 0.42 meters per second. So that's how fast he's going in elevation, or how fast his vertical elevation is changing. That's not the answer though, because that's telling us in meters per second how much it's changing, but we need to take that from meters per second into a distance. So we'll be using the velocity equation. V is equal to the change in a distance over the change in time. We'll multiply both sides of the equation by time. And then rewriting that gives us delta x is equal to velocity times the change in time. We already have the velocity, so we have delta x is equal to this right here, 0.42 meters per second. We want to multiply that by 60 seconds. So now looking at the units, we'll have meters over seconds times seconds. These will cancel, leaving us with meters. So we'll have meters here. 0.42 times 60 gives us a distance in 1 minute of 25.2 or 25 meters is how fast his elevation is he's gaining in 1 minute.